Hi, folks. Thanks for being here, and I'm really happy to see you today. We've got 2 days of wonderful talks, and your brains are probably full of new tools or new concepts that you want to use when you're going back to work tomorrow or next week, I don't know. But let me add one more, just one, for a few, OK? Just for fun. We're going to talk about the zero-build pipeline and how it could improve your developer experience in your daily process. So let's dive in. To be short, first thing is we're the only industry that ensure a backward compatibility for 30 years. Because what we developed 30 years ago still works today in our modern browsers. So we do have to ensure this retro-compatibility, this backward compatibility. This is important, and we are the only industry that is really doing that right now. Second thing is you should improve your developer experience by upgrading your dev tools. Now, this is mandatory because developing for the web right now becomes more and more painful, and we have to decrease the complexity of working with our dev tools in our everyday development. And three, this upgrade should not be more than just updating one single file in our repositories. So let's see how to do that. We work with the web platform and the web technologies. So we are working with HTML, CSS, and JavaScript, and so on. But modern web stack doesn't use those languages anymore. We are focusing on modern stack and complex stack. And it becomes more and more complicated to just having a modern web stack that we are able to run every day. The fact is, I'm old. And I mean really old. I released my first website 25 years ago. 25 years ago, I just built some kind of few HTML, few styles that will become CSS after that, and a few JavaScript and Java applets. Sorry for that. But yeah, nowadays, I could still use them, but I won't be able to power a modern stack with just those tools. Why? Because we are now using template engines, we are using preprocessors and post-processors in CSS. We are using a reactive framework like React or Vue or Svelte or whatever you want. We have some packers and some bundlers. We have some dev tools with Arch Reloading and HTML and so on and so on and so on. And this stack is more and more complex. But you didn't see HTML and CSS and JavaScript in those lists because we are not using them right now. This is not the same thing developing today than developing 30 years ago. The problem is, each time I want to use them and I want to start a new project, I'm just waiting so long for a while just because my whole stack is recompiled and bundled before everything is served in my web browser. And each time I just want to add a new feature or debug some web application, I have to wait 5 minutes before having something that is just prompting in my browser. And this is insane. We're not supposed to work like that. We are supposed to do something more smooth in our everyday work. So why do we compile a website right now? The first thing is that our total developer experience is totally bloated just because of our dev tools. If you want to work something like 10 years ago or 15 years ago in your browser, you just had to add some line to just include some kind of JavaScript file, and we start to just put everything in a dump content loaded event and started to work with that. And that's all. And it was pretty much enough. The problem with this pattern is that we are polluting the global namespace of our overall concept, your overall stack machine in your JavaScript engine on your browser. So we wanted to sandbox every part of our application to prevent this kind of leaks and this kind of polluting. So we started to work with the modules concept. And the modules are not more than some IFI functions that are automatically executed function in JavaScript. This way, we could take care of our namespaces and the way our variables are exposed to the rest of our application. But having that means that we need some way to export and import some values inside and outside our modules. So we started to work on a new format, which was the CommonJS format, with some kind of export and some kind of imports. And everything went well. But the problem is, your browser can't understand the CommonJS format natively. This is not what it does. So we had to find some ways, some kind of tools that are able to convert some kind of modules in the CommonJS format to something that is able to run into the browser by itself. This was before we invented and standardized the new ESM format that is now running anywhere in any browser and even in Node.js, as we saw in previous talks. So building for the web start at this time. We had to pack everything and to bundle everything into the same file just to help browsers to run our JavaScript concept. Then we had the transpilers. It started with ActiveScript from Flash, and then from CoffeeScript, and now we have TypeScript, and TypeScript is everywhere. But TypeScript isn't run natively in your browser. You still have to convert it to JavaScript, to transpile it, to be able to run it, just because your browser don't understand anything more than the JavaScript by itself. And there is no other language. So we're still using JavaScript, and there will be JavaScript only in your browser, except in this new browser as a VM era, because we moved from a browser that is here to display documents to something that is able to run as a virtual machine. And nowadays, your browser is definitely a virtual machine. This is a web platform by itself, and we run new formats like WebAssembly. So we are now able to write any kind of data, any kind of logic in any language that could compile, to just compile it to the WebAssembly format and having it running into our browser. So this is why we're compiling websites right now. We have modules to support. We have transpilers to convert to JavaScript. You have new formats that you need to support, like WebAssembly. But the performance still matters. And we can't just trash the shitload of data to our end user's browser. We need something that is still optimized and still shrinked to be served to our end users, because this performance is really important, and we don't have the control on it because we are running on a non-standard platform, a non-straight platform. That is a web browser. So the web evolved. We're still using HTML and CSS and JavaScript because they are the backbone foundations of the web. But we are not using them anymore. We are using iDev tools because those dev tools help us to improve our developer experience. So nowadays, when you want to work with a new project and a new modern web stack, we had to improve our developer system and our developer experience. So the usual suspects are still the same. We're probably using Webpack to pack every part of your application, the static assets, JavaScript, CSS, and so on. We still have Rollup and Parcel behind the Webpack that is bundling everything in the same part. We have some testing suites. You have probably TypeScript or something like that to transpile your content. We have some tools to reformat the code, some tools to check the code, some tools to manage the dependencies, some tools dedicated to your own framework that you are using, like React or Svelte or Vue, and so on. So this is my common dev stack, and this is insane. Why do I need all those tools just to power some kind of view into my browser? Because I don't want to take my time to just configure and reconfigure any time of your stack on my application just to be able to run something in my browser. I just want to dev, and I want to be focused on the code because this is my job. And I'm not a tool configurator. This is not what I do. So compiling for production, because this is what we are talking to. We are talking of just compiling the content to push it into our end user's browser. But because we are compiling for production doesn't mean that we do need to do it for the development process. This is two different things. And I don't want to compile everything when I do my bug track or my new features implementation. Just want to develop it, and that's all. So we have now some kind of superpowers. We've got JavaScript modules that are supported everywhere. We've got advanced cache policies that are directly available in our web browsers. And we've got the HTTP and HTTP2 protocol that help us to support and to send chunks of data and chunks of code at any point in your browser. So improving now the developer experience is to use the standardized JavaScript modules directly with probably a superset of language, because I want to still use TypeScript, because this is awesome, and I just want to continue to use it. I want to be free to load the whole NPM registry locally each time I want to develop a new feature. I just want to use the kind of modules that I want, and that's all. I need an instant startup, hot module reloading, and I need something that is extensible and that I could configure for my own needs, because my application has probably some specificities that I need to take care of. So how to solve that bottleneck right now? So how does it work? Working in this new era of dev tools, we will use native ESM modules right in the browser. I won't use the command.js format anymore. I just want to type import my module to have it available in my code base and have it available in my browser. Because my browser is supporting the native ES modules, I don't have to convert it to anything anymore. If I want to use some dependencies that is not in the ESM format, I will convert it to the ESM format before, so it will be available in my browser and read directly by my browser in a native format. I will cache all my modules into the browser by itself. So each time I want to add a new feature, I don't have to recompile my whole application, and I don't have to recompile the whole React engine or the whole view render core, because I don't need to recompile it. I just need it available in my browser, and that's all. So it will be available in the cache. I will have some HTML that will be available to just reload the parts that I'm working on and not reload the overall application. So I could preserve the state I'm working on without having to reload everything each time I want to make tests. And I will use HTTP and HTTP2 features to push new contents directly to my browser without having, once again, to reload everything. About the dependencies, they will be loaded from my node modules directly. I don't want to export them to a dist folder or something like that. They're available in an ASM format in my node modules folder. OK, that's fine. So let's use it directly and serve them to the browser directly. And that will be fine. So I won't bundle everything anymore, because I don't need to bundle everything when I develop. I will be able to dynamically load my dependency from the CDN directly, and so I don't have to load them in my node modules folder before having them available in my browser, like Dino does. And I will use the ESM versions. It means that I could definitely use this syntax and directly import confetti, canvas confetti if I want, and this code will work directly in my browser. Simply. I don't have to do anything more than that and pushing that piece of code in my browser, and everything will be running. How does it work? It works based on the routing. This is the schema that represents the native ESM dev server of Vite, the tools from the Vue community. So each time I will request my first application, my page will be analyzed by the browser. The main file will be cached as requested by the browser, read, and each time it will encounter a new dependency, it will ask requests for this dependency to my web dev server. So I don't have to pack anything. Each time I will request a new view, there will be a new code analysis and requesting new dependencies, and everything will be served directly from my node modules or from my code base for my own custom modules. I don't have to do anything more than just pushing my first entry file, and that's all. Why it's interesting and why splitting every file? Because it means that I will have fast builds. Each time, if I want to work with TypeScript, for example, I just have to develop in TypeScript. Each time I save my file, I just transpile my file to the JavaScript and not my entire code base. So the code base is transpiled really fast and served really fast to my final browser. This approach is deterministic, so if I didn't modify any file, I don't need to retranspile it or recompile it. So if it's available in my browser cache, I could use it from my browser cache. So it's easier to debug, no more source map mess that are totally insane. It's just non-related to your code base size, which means I could have just few files or thousands of files. The development time is the same and the serving time is the same, just because I just need to refresh one file at once, and that's all, just because I'm using the cache. This is exactly the difference between using a bundled application where everything is packed and a splitted application where everything is served file by file. So what our challenge is right now, I will just focus on the mainstream ones and probably not talking about the outsiders, but we've got 3 challenges. First one is Snowpack. This is the first one that occurred something like 1 year ago, something like that. It's really lightweight, really fast, totally agnostic. You could use it with any kind of application, any kind of framework, even with Alpine.js or jQuery if you want, it works. It supports the build process using Parcel and Webpack behind the hood. It got a plugin API, but a proprietary one, which means that we probably have to redevelop some kind of plugins at some point, which could be a little bit painful. But it's highly configurable, and if your stack is a bit non-mainstream, like non-React or non-Vue or non-Svelte, it's probably your challenger. In front of it, we've got Vite. Vite is coming from the Vue community. It's actually the leader. It's compatible with Vue. It's compatible with React, Preact. It's compatible with Svelte, with Lit, too, for web components. It's using ESBuilt during the development process to convert the old CommonJS format to the ESM format and to handle the TypeScript file natively. It supports multi-pages, which is really, really awesome. It supports library, so it doesn't care if you are working on the final project, a library, a blog, a static site, whatever you want. Vite could be used tool. It could be yours. It has a CSS code splitting and uses the rollup API behind the hood. So we could reuse the rollup plugins that are already existing. And the final one is WMR. WMR is coming from the Preact team. It's more focusing on the JSX, using native CSS module, native HTML, rollup for the builds, using HTTP2 features. So if you are working with JSX specifically, this is your challenger, definitely. I'm working at a company where developing dev tools. Sweet irony. And we are using Vite as a backend service. We're making Backlight, which is this, which is an online editor dedicated to design systems. And when you are using Backlight, you could add some kind of documentation of stories, developing your components directly into the editor. Each time you made a modification, you have a rendering preview that is powered by Vite in the backend, which means that each time my component is updated, it is HTML reloaded directly into my preview. I don't have to do anything on my side. And most of all, everything runs into the browser, because we used Vite in a service worker, dedicated worker, so we don't have to run anything on the server. Everything is able to run directly from the browser, even the DevTools by itself, which is just awesome. From our experience, we really decrease the rendering time, so we really increase the whole developer experience, because this is blazingly fast to render the preview. We've got the native HTML. It's really quick, even on large code bases. And we've got MDView, but MDView is not standard, so it's a bit shame, but yeah, we have it. At least we had MDX support by modifying some few configuration, but yeah, on the cons, we saw that it's probably more error-prone, because if we miss some dependency in the code analysis process, we had to reload the entire preview. So at some point, we have few glitches with Vite, but definitely our feedback is totally positive. It definitely improved the time and decreased the time that we're waiting each time we want to restart a new project and render a new project. More than in Backlight, we're also powering our whole documentation using VitePress, which is a tool that is able to generate static site with Vue and with Vite in the process by itself. So Vite is at some point everywhere on our stack. So this is for the development part, but we still have to build for the final users. So when I want to build my project, because I'm a developer and the things I want to focus on when I'm developing, like improving my rendering time and having an instant startup, is not what is expected by my end user. My end user is still focusing on performances and optimization. So I still have to build for the production part, but not for the development one. So behind the hood, all those tools are still using advanced and recognized tools. So we are still using rollup or parcel or ES-build to build the process. So nothing to change on this part. We still have the plugin support, so we still have the optimization process, browserless support for legacy browsers, some code splitting, and we've got the tree shaking because we are focusing on native ESM modules. The tree shaking allows you to drastically decrease the size of your application because each time you compile, you are just dropping off any part of code that is not really used in your application, in your dependencies, and in your code base, thanks to code analysis. So the fact that we are not developing in the CommonJS format anymore, but we are developing using the native ECMAScript modules, allow us to take advantage of the tree shaking method at any part of our application, even if in our dependencies. And if I want to extend it, I still have a great API for my plugin. So everything is available directly. So it's really exciting because it's a new generation of dev tools, probably a new war, but this time not powered by vendors like the browser wars, but led by great communities like Skypack or Vue or Preact communities, which is really cool. And side of that, we saw new projects that are able to take advantage of that, like ESM-oriented registries that are distributing the same modules at NPM, but in the native ESM format directly, like Skypack, like ESM.js, JSPM, and so on. So that's pretty cool, because I could use directly the ESM version of my modules from the CDN. I've got new advanced tools that take care of this Vite implementation, like VitePress, like SlideDev, like ViteChat, and so on. So this new generation of dev tools allow us to develop new tools that we can't have before that, which is really, really nice. And it's really easy to plug into your actual project, actual development. It just works with any kind of imports, because if you are focusing on ESM format right now, it will work. And if you are working with TypeScript, it will work. You probably have some kind of few adjustment of the side, like pass request or something like that. You have to update your NPM scripts, and you have to drop Webpack support to finally just add a default vite.config.js file, and that's all. We made a PR on Cresus app. Cresus is an open source banking application developed in TypeScript. And we are just enough with the Webpack support that broke at some point. And we wanted something really, really more useful to do that. So we focused on Vite, and we made a PR. And the PR took just 1 hour and a half to one person in one evening to just drop the Webpack support and add the Vite support. The PR is available on GitLab. And 90% of this PR is just moving the path for the static assets, and that's all. So moving from your existing stack to a new bare module stack, like with Vite or Snowpack, is just a few adjustments and a single file to replace. In something like 1 hour, it will be done. So just keep in mind that, like George Orwell said, who controls the past controls the future. It means we went to this situation with a bloated DevTools stack because we need, at some point, to convert for the browser to have native support. But right now, our browsers evolved, and they are available to take care of native, standard, native modules. And we don't need this overly complex stack anymore. So it's time to drop the support of the stack and just enjoy a new era of DevTools just to improve our developer experience. Thank you very much. I'm Mads. I'm a developer evangelist at RIOTS. So we're working on DevTools to improve the design system and web components. If you want to talk about it, feel free to come to talk. And thank you very much for your attention.
Thank you so much.